7.5, derivative notation level 2. Given that x equals 2w to the fifth minus 1, find the derivative with respect to w of this function in terms of only w. Okay, so I'm going to show you one way first, that to me, if I had this problem, this is probably the way I would do it. But again, this is baby steps into the next lesson, which is actually implicit differentiation. So way number one would be to do a substitution. So if x is this, 2w to the fifth minus 1, I'm going to replace x with that so that I do have w's. So I would have my function be 3 times 2w to the fifth minus 1 raised to the third power minus 5 sine of w. And then I better do brackets. They want me to take the derivative with respect to w. And so I'm going to do the chain rule. 3 times 3 would be 9. Keep the inside the same. Subtract 1 from the power times the derivative of the inside, which would be times 10w to the fourth. And then this one would be derivative of sine is cosine. So the negative doesn't change. And then I'm just taking it with respect to w. And so that would be my answer, which I could, of course, multiply these to get 90 w to the fourth times 2w to the fifth minus 1 quantity squared. Okay. That's not the way I want you to do it on this lesson. So now I'm going to show you kind of the implicit way. So I'm going to write my function again. 3x cubed minus 5 times sine of w. I want to put brackets around it and put d over dw. So I'm taking the derivative of this function in respect to w. The problem's going to be when I have variables that are not w. So like I see this x. That's when it gets weird. But here's what's going to happen. I'm still going to take the derivative of this the same way. So that would be chain rule is 9x squared. But then I would have to take the derivative of x, which I'm going to multiply here and get dx over dw. I know it's weird. Stay with me. So times dx over dw. That's just a derivative of x in respect to w because we don't know what x is. Okay, and then here would be minus 5 cosine of w. I don't have to do anything with the w because w is what I was in terms of. I mean, I could do dw over dw, but we found out that's 1 anyway. So the only time it's weird is when you have a variable that doesn't match what's in the denominator. Okay, and so then what they want me to do is to get it in terms of only w. And so we need to replace, first of all, x here, and I have to have the derivative to plug in there. So I would have 9 times 2w to the fifth minus 1 quantity squared times the derivative of this, which is 10w to the fourth, and then keep going, minus 5 cosine of w. So you can see how this is the exact same thing. That's why it works. I'm not going to simplify on that one. So you can choose to simplify on delta math or not. Okay, so let's try number 2, not doing this way, but getting used to doing it this way. We have an equation for y. We're going to ignore that for right now. We're finding the derivative with respect to x of this. So the problem I see is that I have a y here, and so I'm going to have to do something special with that. So I'm going to take the derivative like normal. That would be 6y squared. But then I'm taking the derivative of y with respect to x. So I would say dy over dx. And then derivative of sine is cosine. So it would be minus cosine of x. Nothing special with the x because it was in with respect to x. And so then I need to do two things. I need to replace y with this. And I need to find the derivative of this. So it'd be 6 times x to the fifth plus 2 quantity squared times, that would be 5x to the fourth, and then minus cosine of x. Of course, if you want to fix it a little bit, you could take your 6 times 5x to the fourth, and then that would be your answer that has only x's in it.